Okay, so I'm going to do the first part, but I'm going to go over the stuff. I'm not going to go over it in depth because you're not going to be asked this stuff. You should know it. So, and it's important. So we're collecting numerical data, and so there's two types of numerical data. There's continuous, and there's discrete. Now, we're not obviously. There's going to be a test, and they're not going to ask you this stuff, but you should just know it. So once again, continuous is something that you measure, like weight, the time, how fast, how much rain fell, and the discrete is something you count. How many people are in the room? How many how many people are in the room? Something that you count. How many days are there? Or I don't know. Something that you count. How many shovels do you need? How many people do you need? How many apartments are there? How many rooms are there that you count? So the first word is something univariate. And the idea, can you see the marker? Should I get a new one? No, we're good. So the idea with the univariate data is that there's just one piece of information or one variable. So it's like it would be like one question or like one piece of information. And for example, what are the ages of the student in your school? Done. How many inches of rain fell every year? That's it. And we're just collect those numbers, right? And we're gonna do a bunch of things. So discrete, how many sweaters do you have? How many clubs are you in? Continuous, how fast did you run? How many centimeters of rain fell? So you collect all this data, right? But it's like one question. And so the next thing we want to look at is how to organize. Now, I'm going to talk about the different methods, and you're not going to ask to do it. You might be asked to do it in your science or economics class or history class. But here you're going to be given charts. I'm trying to show you what they look like. Well, the first thing is, let's talk about organizing data. And so always, if possible, list it in ascending order. If possible, let me throw this pen up. To the next one. If possible, list in ascending order. If possible. So the first thing we're going to talk about is stem and leaf. It's rarely used. It might show up. It's there. I'm just talking about it. So here's our data points: 5, 8, 15, 17, 23, 23, 30, 31, 39, and 46. And so the idea behind the stem and leaf is that you break up all these numbers. So you're going to write this as like 0, 5, 0, 5, 0, 8. What you're going to do is you're going to draw a line between either the tens and the 10 and the ones digit, or like everything in the ones, like da 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 da. And then the idea is this is the stem and this is the leaf. And so you make a stem and leaf table. So it's like the stem 0, 1, 2, 3, 4, and then you write the leaves of the numbers. So the first leaf, let's make it in. Let's see. There's 5, and there's 8, and then for the stem, how many numbers have a stem of 1? There's the 5 and the 7. How many? There's a 3 and a 3, because I want to denotes that 23 occurs twice. I have 30, 31, 39, and then 46. So this is the stem and leaf. This is more like 8th grade, 9th grade stuff, but it's a way to organize your data. Another way to organize data is this is method 1. Another thing you might want to do, is called a frequency distribution table. Now, sometimes frequency distribution table. These generally have 2 columns. Okay, and so let's assume that let's say, here's some data. 1, 1, 1, 2, 3, 3, 4, 5, 5, 6, 6, 6, 6. And the idea is, obviously, in the 21st century, you'll have technology to sort this out. So you want to condense it. So the idea is you make a frequency distribution table. So I want to know, first of all, there's 2 columns. I want to know what the data point is, and I want to know how often it occurs. So you say, okay, there's 6 different 1, 2, 3, 4, 5, 6, and then the next column is the frequency. And we can see how it's distributed or spread out. So let's see, 1 occurs 3 times, 2 occurs once, 3 occurs 2 times, 4 occurs once, 5 twice, and 6 4 times. Nice. So this is the idea of a frequency distribution table. Now, what's the problem here? Well, it's not a problem per se, but you know that how many points are, let's see, 4, 6, 7, 10. So there's 14. We know that, from your science classes or your economics classes, you don't collect 14 pieces of data. You collect hundreds of pieces of data, a lot of pieces of data. And we know that the answers most likely in our classes are not 1 through 6. Most of the time it's not discrete. In your science classes, you're collecting continuous data, like how many centimeters did the plant grow, or how far did the object move. So the idea is we're going to make frequency distribution tables, but using intervals. So we're going to make frequency, the third way is frequency distribution tables with intervals. Okay, and I'm going to ask you, I'm going to make these tables, and then when we move on to the next unit, which is mean, median, and mode, I'm going to ask you to come back and look at some of this work. So I'm going to leave it up here. So I'm not going to I'm just going to rate the structure of the table for discrete data. I'm going to throw this pen out also. For discrete data, so the idea is, sorry about that. So we're going to look at 2 tables, discrete and continuous. And so the idea, so let's look at the first table. We're going to look at the data, obviously the data, and there's frequency. But with an interval, I'm not writing individual pieces of data, I'm writing intervals of data. So for example, for the discrete, I write 1 to 10, 11 to 20, 21 to 30, and 31 to 40. The idea, first of all, so the intervals are equal. Intervals are equal length. And because it's discrete, there's no 10.5. This is a counting. So it's 1 to 10. How many people showed up? 10. How many people showed up? 11. There's no 10.5. And so you count up. So you imagine you have 1,000 pieces of data, and so instead of giving every single line 1, 2, 3, 4, 5, 7, you lump it in together with 1 through 10. The continuous is a little different. Same idea. You have the data, and you have the frequency, but the intervals look a little different. So here, we're going to go 0 to everything less than 10. Now, because you're counting, you can only have 1, but when you're measuring something, you could have like 0.58 centimeters or 0.79. So we want to go to 0 and everything up to, but not including 10. So in the next row that you'll see, you're not ever going to be asked to do this, you'll just see it. It's 10 up to, but not including 20, 20 up to, but not including 30, and, 30 up to, but not including 40. And that's the structure of the table. Same idea. The lengths are, the individual are equal length, but you can kind of see the slight difference between the discrete and the continuous. As I said before, you're not going to be asked to waste your time on an exam doing this, and computers can do this for you. But once again, it's you still, as the programmer of the organization of data, still have to decide what to tell the computer to do. Okay, let's move on. Well, we know that much to go. Okay, so we've organized. This is how the data is organized. This is how the data is organized. The question now is, what's the conclusions we're going to draw? What can we infer from this data? And so the idea is, the next thing is representing that, representing the data, and a couple of things. Now, you know the mean, median, and a mode. That's what you've been taught. That's the first thing you've been taught about how to represent the data. It's the fancy name is the measures of central tendency. And that's just a fancy way of what's kind of the middle, what kind of represents the center. We're going to learn a normal distribution in a couple of lessons that you've been collecting all this data and there's kind of a center. And that's kind of how it goes. It's mean, median, and mode. So let's just talk about what these things are. The first thing you need to do in every single time you collect data is find out how many pieces of data are there. That's the first thing. First, find your N, which is the number of data you have. Now, from your science class, your economics class, your psychology class, all this stuff, the first thing you have to say is N, we looked at N plants, we hooked to N people, we measured N days. That's the first thing you say. We looked at N subjects. That's the important thing. Once you have that, the question, so first of all, how do I find the data I have? Well, you can either count it up, so that first sum and leaf problem, if you go back to the original, let's see, if I gave you sum and leaf, you literally can count it up. 1, 2, let's see, 5, 8, 15, 17, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that stem and leaf problem, N was 10. So for the stem and leaf, N equals 10. Or in general, what can you do? Well, you look at your frequency column and you have your computer or technology, do a summation. So right here, N is 14. So the frequency distribution table, N equals 14. Over here, once again, you'd add up. So you'd add up sum to figure out what the N is, add it up to figure out what the frequency is. Okay. Next, you have N pieces of data. Well, the first thing we're going to look at is the mean. Well, the mean is a fancy way for average. How do you find the average? Well, you're gonna add up the N values, add the data values, divided by the number of data values. Very basic. So, for example, So for example, you have 1, 3, 8, 9. What do? You add it up. What's the sum? 1, 4, 12, 21. How many points? The n is 4. Therefore, the mean is 21 divided by 4, which is 5.25. This is the symbol for mean. Another thing I didn't talk about was mean, something called the sample versus a population. We're not getting into it in this course, but you might have to get into it in your science classes. But we're just going to use this symbol for mean. Symbol for the mean. This technically is the symbol for the sample. If you manage to get the entire population, so for a population, we use m, but so that's rare. Anyway, how do we find? Good. Let's move on. How do we find the mean from the frequency tables? Well, that's easy. So finding the mean from a frequency table. Okay, by hand. Okay. So we found the mean given like 4 pieces of data. The question is, what are we good with it? Yeah. So the question is, what happens when we have frequency tables? Well, it's very basic. Just take the data point times the frequency. So for example, let's make up a new table. So from a frequency table, for example, here's a table, right? Here is the data. Here's the frequency. And for example, here we have 1, 3, 8, 9. But let's say in this new case, this 1 occurs 5 times, 3 occurs 6 times, 8 occurs 2 times, and 9 occurs 3 times. The first thing we want to know exactly how. So you're going to look at this chart, or you're the statistician. Someone has handed you this data in an Excel spreadsheet, and this is how the computer organized it. You're like, how many pieces of data? How many pieces did you collect? You go, okay, well, let's see. There were 5 1s, 6 3s, 2 8s, and 3 9s. 11, 12, 13, 11, 13. So there were 16 pieces of data. Okay, the question is, how do I find the mean? Well, what you do is, you're going to do something called x times f. Okay, if we call this data point xi, right, and this specific frequency called fi, so this is 1 times 5, or 5, like 1, 1, 1, 1, 1. 3 times 6 is 18. A 3, 3, 3, 3, 3, 3. 8 times 2 is 16, and 8, and then 8. And 9 times 3 is 27. That'll be like the 9, the 9, and the 9. Well, once again, the technology is doing this, and obviously I'll show you. This is by hand. So let's see, 5, 23, 39, 66. So the sum of the 16 pieces of data was 66. What kids do is they'll do 16, or they'll add these up and divide by 4. And I'm like, no. You have 16 pieces of data. As I said before, you're never going to have to do this by hand. So, hey Siri, 16 divided by 6. Forget it. Hey Siri.
16 divided by 6 is about 2.6666.
Hey Siri. 66 divided by 16.
66 divided by 16 is 4.125.
4.13. The mean is 4.13. Last thing I want to talk about with the mean, the question is, what do you do? So you're looking at this chart and you're like, okay, I have a bunch of data points and frequency. And you might say, well, do I go through every single point and multiply by the frequency. No, what you're going to do, which you might have to do on the paper, because you might be asked this, once again, probably not. What you're going to do is take an average of the endpoints of the intervals. So to find them, so once again, so to find the mean in a frequency distribution table with intervals is basically use the average of the max and min of the interval, use the average of the max and the min of the interval to represent every point in that interval. So use the average of the max and the min of the interval to represent all points in the interval. So, once again, probably not going to be asked this, but can you see that? Use the average of max. Yeah, so, kind of tedious. The SL kids get this, and the studies kids get it. You might not, but let's see. In this case, 1 plus 10 is 11. 11 divided by 2, 5.5. So 5.5 is going to be representing the total frequency. It works out. You'll say it's in advanced stats in college, why that works. What's going on here? Well, this would be 15.5. Yeah. Let's see, what's going on here? Let's see, 30 plus 21 is 51 divided by 2. 4, carry the 1, 5, 5. This is, I'm sorry. 25.5, and this is 35.5. So once again, maybe you have a frequency of like, this is 6 and 9 and 1 and 3. You would say 5.5 times 6. 15.5 times 9, 25.5 times 1, and 35.5 times 3. It works, don't ask why, until later. Same thing here, 0, this one's, you'll probably be asking the continuous, how do we represent all the data points in this interval? Well, this is 5, 15, 25, 35. This is the number that represents. So, when you go to tell the computer, it's like, you know what? However many points were in this interval, use 5 to represent it. How are you doing for time? Okay, we're good. And that's the idea of finding the mean in an individual that you can count, a single frequency table, and then finding the mean when you have distribution tables with intervals. Okay. I'm going to obviously show you how to do this in the technology, but I just want you to know what's going on behind the scenes. And then, yeah, so now you're definitely not going to be asked with it. This is not good. You might be asked to do this with the continuous. And so, the idea is you do the same thing that you did here. Good. Mode. I'm going to keep everything up. Mode. Mode is not the number that occurs the most. Mode is the number that occurs more than the others. Data, it's data that occurs. Sorry, guys, and sorry, folks. It's data that occurs more than the others. So if there's 4 pieces, if let's say there's data like 1, 2, 3, 4, there is no mode. Something has to pop Something has to be more than the other. Something has to be the maximum. And so when we have the marriage of statistics and calculus, you're going to find the maximum of a function, and that's the mode. So the idea is, what is more than the other? So let's go through. Does this piece of data have a mode? No, there's no mode here. There's no mode. Nothing pops up. 1, 3, 8, 9. I don't know what's going on. Like you got, I don't know. You have 1 sweater. You have 3 sweaters. You have 8 sweaters. You have 9 sweaters. I can't tell anything about the population. Does this data have a mode? You say, yes, Mr. Adler. 3 is the mode because it's the highest frequency. 3 is the mode because 3 occurs more often than the others. Now, you're not going to be asked, if you ask about mode, they're not going to do bimodal, trimodal. They're not going to do that. What they're interested in is something. So hold on a second. Let's see. 9, 2, 1, 11. Now, the question is now, what's the mode with these intervals? And you're not going to be asked to like sift through the data within the intervals. But what you are going to be asked is, what is the modal class? Because you might say, Mr. Adler, this interval has more than the others. This interval has more than no, I'm sorry, I apologize. This interval and then this interval seems to have more than the others. So the modal class is the interval with the greatest number of data. So you can say, and that's the idea. So that's how we find the mode. That's how we find the mode when we have interval tables. Once again, we're not interested, we're really moving away from like individual pieces of data, and now we're clumping it together. So we're saying, okay, you know what? The 30 to 40 age group, that's the mode. Over here, the 11 to, this is the 30 to 40 age group is, the mode. In this curve, the 11 to 12, number of students in schools in Bangladesh or something like that. This seems to be the modal class. We don't know individually who's the greatest within, but we're just saying when we lump these together, in this interval, this modal class is the mode. This interval is the modal class. Last but not least is the median. Last but not least is the median. And this is what we like. Median, so I'm gonna check out, let me see if I need these. I'll rewrite the table. I'll read it. So median. Median's kind of the big one. Actually, it's really important. Because if you think about it, we know that you've learned that median, I call it the organized middle. And you literally take your data, put it in order, and then literally find the middle piece of data. Why this is so important is because if you add another piece of data, it really can knock the middle off. If you think about it, the joke is like, there's 100 people in the neighborhood and Bill Gates. Now, if you took the average of everyone's salary plus Bill Gates, everyone would be a billionaire, but we know that's not true. The median corrects that because it doesn't matter if Bill Gates joins your neighborhood, that center is still going to be around the 100 people who live in the neighborhood. So, once again, the organized middle, first find the n, right? And then we have a couple, you've learned in the past that if n is odd, then n plus 1 over 2 points is the median. And that makes sense if you think about that. Let's make an odd number of data points. First, second, third, fourth, fifth, sixth, seventh. Here's 7 data points. I don't know what they represent. The question is, I can say, what's the average? You go, I don't know, Mr. Adler. It's, you can say the average is, what is it? 1, 3, 11, 20, 33, 41, 60. So 60 divided by 7. Hey, Siri. 60 divided by 7.
60 divided by 7 is about 8.5714.
857. That's the average. What's the mode? The mode is 19 because 19 occurs more than the others. And the question is, what's the median? And you say, okay, well, I'm literally gonna, let's see. What I do is, I teach the kids little tricks. You never have to do this, and the calculator will actually tell you what it is. I go cross up, lowest, top, high, low, high, low, high, low, center. This is my median. Or n plus 1, so there's n, there's 7. So 7 plus 1 divided by 2 is the fourth piece of data. Let's see, 1, 2, 3, 4. Nice. How do we find the median if there's an even number data? So if n is even, the rule is take the average of n over 2 plus 1, n over 2, and n over 2 plus 1. Personally, well, you kind of need to know where the center is, but it's not difficult. So for example, let's say we have 1, 5, 8, 9, 17, 20, 1, 2, 3, 4, 5, 6, 7, 8. You're like, fine. High, low, high, low, high, low, the middle, take the average, divide by 2. So the average is 13, therefore the median is 13. Let's see, we know that we have 8 pieces of data, so it's between the 4th and the 5th, the average of the 4th and the 5th, that makes sense. And you've done that, and we can do some exercises. The question now is, how do we figure it out with these frequency tables? Because I can't lay the data out in front of me. Okay, the question, once again, the question is, how do I do these with frequency tables? And, how do I find the median with frequency tables? And so, the idea is, you're gonna make, finding the median with a frequency table. So let's make a table. Let me see if I can get the last. I really want a black pen, but I'm running out of ink. Yeah. So let's see. So we collected some data. I'm just going to use anything. Well, it doesn't really matter. Here's our data. And here's our frequency. Now I know, let's see, there's 3, 4, 1, 8, and 5. So the question is, how do I find the middle? Well, we're gonna make another column called the cumulative frequency, and we're gonna see how the data increases. Now, let me just use. Let's say this is less than 10. 0 to 10, 10 to less than 20. Let's see, 20 less than 30. This is 30 less than 40. And this last data interval is 40 less than 50. So in this, what I'm going to do is accumulate the frequency. So let's see, how many pieces of data were less than 10? You said 3. Now we're going to add that to 3 plus 4 to give me 7. That means there were 7 pieces of data less than 20. Let's accumulate some more. There's now 8 pieces of data that were less than 30. Let's accumulate. Can you see me? All that? Yeah. Sorry. Let's go some more. 8 plus 8 is 16. There's 16 pieces of data less than 40. Now let's accumulate even further, 21. So there's 21 pieces of data less than 50. Well, it turns out our n is 21. This is perfect. So now, because you know how to find the median, right? So we have an odd number, and you're like, okay, well, what's half of 10? So you know what? It's 21. Sorry, this is dead. So how do we find the median? Well, we're lucky, it's odd. So we know that n, so it's let's see, 21 plus 1 divided by 2. Let's see, 22 divided by 2 is 11. So we go to the 11th, we go 3. So this is 11. So we 3, 7, 8, here, 16. This is where the 11th pieces of data is. So this is where the first 3 pieces of data are, right? This is where the first 7 pieces of data are. This is where the first 8 pieces of data are. And so the question is, the 11th piece of data is in this interval. So 30 to less than 40 is the median. Once again, I don't know what specific piece of data is, but I know that it's in this interval, and that's the idea. So once again, when you find the median for a frequency table, add on this new column called the cumulative frequency, start adding up the frequencies, and this will tell you where the data point is. It won't tell you, once again, with this data, it won't tell you what the data is, unless you have a supercomputer that can do it for you. And once again, so that makes this lesson kind of silly in the 21st century, but you might be asked, where's the median? And you know the median is in the interval from 30 to 40. And I think we're done. We're good.